Hi, I'm gonna work in this video on a simple problem. In fact, I've used this algorithm in a previous video before solving this. Here they want us to find the Hamming weight, and they're telling us to write a function that takes an integer, an unsigned integer, and returns the number of 1 bits that it has. Here, for example, we have 3 ones, the output is 3. Here we have 1 1, the output is 1. So let's take a number. Let's see how we can deal with a similar problem. We have these, and the first thing that might come to mind is to convert these into an array and then check if each element in this array is 1 or not. Or we can go for a different approach. We can check each bit alone without converting to an array. So I can check here if this is 1, and then I'll create a variable that will count the number of ones, and I'll increase it every time I encounter a 1. So here I have 1, here I have 1, so I'll increase num1s, and then I'll move to here and increase it again. We notice here that the function's input is of type int. Ints are typically stored in binary at the end of the day. So we can perform an AND operation. Now if I have 2 bits that I'm ANDing, so I have x, y, and I'm performing an AND operation between them. If I have 0 and 0, this will give me 0. If I have x 0 and y equal to 1, this will also give me 0. If I have x equal to 1 and y equal to 0, this will also give me 0. And it will only give me 1 in case both x and y were equal to 1. So if I take here 1 and AND it with this one, it will give me 1 in case I had the last bit equal to 1. If the last bit was equal to 0, this will give me 0. So I can perform an AND for this number with 1. This will fill all the other bits with zeros, and I have 1 here. So if I have, if this AND operation returned 1, I'll increase num1s. If it doesn't, if I have 0 here, I won't increase num1s. So in this case, num1s isn't increased. If I change this to 1, num1s is increased by 1. So let's try to implement this. I'll create a variable, and I'll call it num1s, and I'll initialize it to 0, and I'll enter a for loop to check all the bits in this. And here it tells us that we have at most 32 bits if we scroll here. So I'll span from 0, from int I equals 0 till I less than 32, and these are 32. This will cover the 32 bits from 0 till 31, and I'll increase I with every iteration. Let's start with the first bit and then see how we can check the other bits. We have, as I explained before, we're taking this number n, and I'm performing an AND operation with 1. So I have n bitwise operation 1, and I can put it inside an if statement. So if n and 1 equals to 1, or I can use it directly. Since this will return 1 here with the rest zeros, this will translate into an integer that's equal to 1 as well, and therefore I'll take num1s and increase it by the result of n and 1. So if n and 1 resulted in 1, num1s will be increased by 1. If n and 1 resulted in 0, num1s won't be increased. I covered the first bit, and I want to move to the next bit. So I can move this here. I want to change this one to 1 0 to check for this one, and this is 1 and 1. This will give 1. So this already gave us 1, and then I'll move the 1 to here, and these are zeros. So every time I'm rotating to the left or multiplying by 2, and this is 0 and 1, it will give us 0. Or I can follow another approach. Let's go back to this state. I have 1 here. I'll keep the 1 here, and I can instead shift these. So I can take this one, shift it to the right. I lose this, and I'll have a 0 here. And the new result will be ANDed with 1 as well. I already had 1, and this new result will also be ANDed with 1. And then I'll shift these again to the right. This will result in a 0 here, and I lose this one. This time I have 0 ANDed with 1, so this will result in 0. Num1s won't be increased, and I'll keep repeating this. So I'll shift it again and again. Now I have 1 and 1. This will result in 1. Num1s will be increased. I'll do this 32 times. I'll take n and I will shift it to the right by 1. So I have n, and these indicate that I want to shift it bitwise to the right by 1 bit. So I can specify here the number of bits that I want to shift to the right. At this point, we are done. So we can return num1s and run our test. It seems to be working. Let's try another example. And let's submit it. The interesting thing here is that we didn't create an array, and in fact, we used only one additional variable. So that was it. It was a simple problem this time. Thanks for watching.